Continuing with angles and arc relationships, there are a few slides here that are very explicit about the notation for arc addition. Even though we've kind of already done it, we've done it definitely with line segments and we've done it with angles and we've had a little practice with arcs. Here it's going to be explicitly stated. So if the measure of arc BC plus the measure of arc CD, that's going to equal the measure of this arc BD. It's arc addition. All right, so you can say that I've added arc BC and the measure of arc CD. That's their length, that's their measurement. Well, of course, they're going to equal when you add the two arcs together. You can note that resulting arc by the starting point and the ending point, the intercepted points. So, with an understanding that arc AB and BC do not overlap, okay, so there's no part of an arc that's part of both of these arcs, here's our arc addition postulate. The measure of one arc plus the measure of the second arc is going to equal the measure of the combined arc, as long as there's no overlap. Which was true of segments and also true of angles. Which is what this slide was saying. Just like if I have A, O, B, and I have that angle, and I have B, O, C, I can add angles, the measure of angle AOB plus the measure of angle BOC. What is that going to equal? The measure of angle AOC. And in these situations, these are actually the central angles. Here's AOB and here's BOC. I can add the angles or I can add the arcs. And just like we have bisectors and midpoints on segments and angles, here if we have, let's look at this statement, the measure of arc RS equals the measure of arc ST, arc S, RS plus ST plus TQ is this intercepted arc. If the measure of arc RS equals the measure of arc ST, if these two arcs are equal, RS and ST, that must mean that S is the midpoint. So you can have midpoints on arcs, or that must also mean that arc RT is bisected by OS, or bisected at point S. So we can have midpoints and we can have bisection of arcs as well. All right, an inscribed angle. We've talked about a central angle, but an inscribed angle has its vertex on the circle. So angle 1 is considered an inscribed angle because its vertex is on the circle. So let's say the measure of arc AB was 50 degrees. The measure of an inscribed angle is equal to 1/2 the measure of the intercepted arc. So that would mean the measure of angle 1 would be 1/2 of 50 degrees. So that would mean the measure of angle 1 would be a 25-degree angle. We can tell the measure of inscribed angles, it's 1/2 the intercepted arc. Whereas a central angle, it's actually equal. The intercepted arc is equal to the central angle. So it's odd that they put it in words here. You can go ahead and say the measure of the inscribed angle is 1/2 the measure of the intercepted arc. So in a single circle, or if you have two congruent circles, congruent arcs must have congruent central angles. All right, so here's my circle, circle O. Let's say AB is 20 degrees. And let's say CD is also 20 degrees. That must mean angle 1 is congruent with angle 2. If they have the same intercepted arcs, they must have the same central angles. Or the reflex of that, if they have the same central angles, they have congruent arcs. And in a single circle, or if you have two congruent circles, congruent chords have congruent arcs. So let's say the measure of that chord is equal to the measure of that chord. The measure of AB is congruent, or AB is congruent with CD, or the measure of AB is equal to the length of CD. Well, that must also mean that arc AB is congruent with arc CD. Congruent chords have congruent arcs. So congruent chords have congruent arcs, and then we reverse that. Congruent arcs have congruent chords. And then here's another, we kind of touched a little on radii that intercept a chord. Radii that intercept a chord will always bisect the chord. If here's my center, chords that are the same distance from the center. What is the measure of distance? Distance is always the perpendicular measurement. The shortest distance is always a perpendicular line. So if I have these two chords, and they are both the same distance from the center. So this distance equals this distance. Chords that are the same distance from the center, that must mean this chord is congruent with that chord, which would mean this arc is congruent with that arc. So if they have the same distance, the chords are congruent. If the chords are congruent, then they must be the same distance. How about this one? An angle inscribed in a semicircle is always a right angle. I always found this interesting, but remember, inscribed angles are 1/2 the measure of the intercepted arc, remember? Here we're going to have some semicircles. That's a 90-degree angle. How about something that looks more like that? You know what? That's a 90-degree angle. there's a 90-degree angle. Right, because the measure of the inscribed angle is 1/2 the measure of the intercepted arc. Well, what's the intercepted arc of a semicircle? It's 180 degrees, which must mean that the measure of my angle is going to be 90 degrees, which means it's a right angle. And if two inscribed angles intercept the same arc, the angles are congruent. We see this all the time in our diagrams. Let's say this is intercepted arc AB. Intercepted arc AB. Well, the measure of angle 1 is going to be 1/2 the arc AB. You know what? Here's another angle that has AB as its intercepted arc. Angle 1 and angle 2 must be congruent because they're intercepted arcs. They have the exact same intercepted arc, so they have the exact same measurement.